Hey there, so in the last video, I went ahead and showed you this operating system that I'm building using AI. Yes, AI. So if you're not into I recommend that you stop watching now. But if you are into AI or want to see what is possible with AI to kind of bring life and new applications and new use cases to old computers, then keep on watching because I think this is pretty cool and you might enjoy it and learn some stuff along the way as well if you're not very familiar with the tools that I'm using. But yeah, so in my previous videos, I showed you how I was able to build an operating system that resembles Mac OS for IBM XT class machines. So this is an operating system that still requires that your computer have a BIOS, but it does not rely on DOS. It loads up a boot sector and then it starts loading the assembly code immediately after it starts up. So you can see here, this is an 86 box machine running with an 8086 CPU. And if I go to special and restart, this is exactly how long it takes in this emulation to start up the operating system and have a desktop shown. Now, I I haven't yet run this on an actual machine, and that is gonna happen soon. I'm gonna get it to a place where I can create the disk images and try it out on a real machine. But for now, I'm still using 86 box. And just as a quick recap, what I have working right now is I have preemptive multitasking. So as you can see here, the bounce and the timer, everything is moving and continuing to run using the CPU clock timer. I have a little notepad. I have a clock and this bounce application. We have an about menu, and this is called job right now, but I'm looking for new names. I have some in mind already, but I'm gonna wait a little bit before I rename this. And what else? We also have a disk management view. So we have the ability to see disk A and disk B. And if I see disk B here, I do have a floppy drive mounted. So if I go here and show you the media, you can see here that I do have an image mounted there. And this image has a couple of applications. They have a hello one, and then they have Minesweeper. So you can see here, this is Minesweeper, which it also has flags and all of that. So a little bit of color. I wanted to see a little bit of color, and that does it. Things that I see now are, for example, you see that bounce stopped. So I think there's a maximum of 4 applications at a time that can use the clock. I'm gonna probably increase that. Maybe I'll try doubling it and see how the performance degrades. But before I do that, in this video, I thought it would be kind of cool to see what we can build to see the CPU performance. So I want to build a task manager of sorts that lets me see how much of the CPU we're using, how much RAM we're using, and to make this video more interesting, I want to be able to build 4 or 5 different versions of it using different AI models. Now I'm going to start with the lowest model that Anthropic has right now, which is Haiku. And I don't know if that one's going to be able to do anything, but we're going to give it a try. So at the end, I'm going to have several branches and we're going to try to see which one did the best job. I'm assuming that the latest model is going to do the best job, but that's not always the case. All right, so let me go ahead and do that. I'm gonna go ahead and shut this down. I'm gonna power that down, and I'm gonna go down here to my terminal. And I already have Claude Code open here, and I am in the main branch of my computer. So I'm gonna go here. I use Danger because I don't have it except anyway. I have Claude Code running with bypassing permissions so that I don't have to ever worry about approving things. So I don't recommend you do that if if you have a sensitive computer, it can go crazy on you if you don't, if you, in some cases, but I haven't had it done that to me, so your mileage will vary. All right, so as you can see here, we're with Haiku, and I am going to ask it to ultra code a. I don't know if Haiku will do workflows or not. We'll see. But ultra code a um, task manager for this operating system that is part of the main operating system, not the apps disk. Let me move the terminal a little bit because I want to make sure that everything is in view. The task manager should show CPU usage in a visual way. And I'm going to leave it vague on purpose. And total system RAM and RAM usage. It should also show the list of running tasks. All right, so very vague on purpose. I'm gonna copy this prompt so I can rerun it. And I'm gonna kick it off. And we'll check on it in a bit to see how it goes. All right, so I can see here that it actually launched a multi-agent workflow. It's going to use 4 agents to build a task manager, understand the kernel architecture, task structures, window system, and memory layout. It's going to plan and then implement it. And then it's going to verify the code for correctness. And then, so let me see, workflows. So this is a Haiku 4.5 task. So it's going to understand with one Haiku agent, then it's going to run a plan, and then it's going to implement the plan, and then verify the plan. So I'm really curious. I normally don't use Haiku for anything other than very basic tasks. So I'm really curious how this one's going to do it. All right, so it finished with Haiku, and let's see what it did here. So this is the understanding part. So here, if we go up and down, so it did an exploration. It found all this information here, 121 lines, I guess, worth of information. It created a plan. So if I go here, it's decided, it created a 400 line, well, an 8,000 line plan, which is quite a lot. It's a lot more than I expected from Haiku. And then it implemented it. So let's go ahead and see in the new tab here. It created all these files and the images. So what I'm going to do now is I am going to make XT and see if it actually runs. So this is the XT machine booting up. And we're going to see right now the operating system loading. And it crashed or something happened. All right, let's try it again. Tools, action, hard reset. All right, so let's restart. All right, so it looks like Haiku didn't succeed. It did not build out the correct stuff. So we're gonna have to move up to the next model because this looks like it's gonna be a failure. And this shows that the progress in AI has been dramatic. The fact that this broke the existing system shows that it's not ready. So, all right, I'm gonna exit this and we're gonna just throw all that stuff away because it's obviously not working. All right, now let's go ahead with Sonnet 5. So we're gonna go Haiku, then Sonnet, then Opus, and then Fable. So I'm gonna go with Sonnet 5, and I'm gonna paste in the the um, the request here, the prompt, and let's see what Sonnet 5 does. So Haiku 4.5 took 20 minutes, and I'm expecting this one to take about the same, hopefully, maybe a little bit longer because it might get it working. So let's give it a shot here and see what happens. Okay, so Sonnet 5 just finished. It took 41 minutes, so twice as long as um, Haiku. And what does it say? It created a new task manager module for the kernel, opened via a new special task manager menu item. CPU usage is a bar percentage for each of the 4 scheduler task slots, and source from a new schedule CPU ticks counter added to the timer ISR, and total conventional memory via int 12, a segmented bar, a loaded plus text lines kernel 22K, etc. Okay, all 4 task slots always shown. Let's see. All right, this looks good. This looks good. So let's see here. Let me go ahead and open a new window here and make XT and see if it runs. Here we go. All right. Just running through the memory test. I wonder if I can escape out of that. Nope. Okay, it's loading. But will it boot into the OS? All right, it got farther. All right, so now we still have the clock, the bounds, and if we have special task manager, nice. So there we go. So we have the UI boot, it's 90%, clock 0%, bounds 0%, and task manager 10% of the CPU. So we have the kernel only takes 22 kilobytes, which is pretty nice actually. We have 256K total, and free is 234K. So it looks like we're taking up all the CPU slots here. So what happens if I go to the B drive? Is it loaded? Let me see. Media. Yeah, the apps are loaded. So I'm gonna go here and load mines. All right, it looks like we need to give it like some prioritization so that the task manager always runs. Maybe like that's why a CPU affinity, so that we can have some tasks that always stay on the CPU. I'm gonna load mines. And I wonder what's app is taking 20K, so that Minesweeper app is taking 20 kilobytes. And the CPU, it's not really counting that, so all right. So the task manager isn't that smart actually. It doesn't measure the CPU usage for the game. Apparently it's only tracking the open applications here that it has in its initial. It doesn't refresh the application list. So That's definitely not what we want. So, okay, so this is Sonnet. Let's go ahead and give Opus a shot. I expect Opus to do a lot better than this, and then I expect Fable to do even better. All right, so here we are now with Opus 5 set up as the default model, and I am gonna paste in my command and let it go at it. And we'll check in with it as soon as it's done. All right, so let's see what Opus decided to build here. So it triggered a workflow with 11 agents across 5 phases. So that's already much more intense than what Sonnet decided to do. And here's the design that it decided on. So it's doing a real, not faked. That's good. All right. Pit channel 0 gets reprogrammed at schedule init from BIOS's mode 3 and mode 2 with the same divisor. Okay, the same 18.2 hertz tick, but the readable counter becomes a clean 0 to 64K down count instead of mode 3's. Okay, which can't be read unambiguously. All right. I don't know. This is doesn't make a lot of sense to me, unfortunately, because I don't know all the internal workings of the IBM XT's architecture. I know how to program chips like in assembly, but you know the x86 assembly is something that is beyond what I could do, and to build something useful anyway. Well, I wouldn't say that because I could build some basic things with assembly, but nothing like this, obviously. And this is all being written, by the way, with assembly. So let's see here. Then it constructs an absolute timestamp and charges the whole interval. So 0.8 microseconds. All right. Let's see what it does with that. Idle versus busy. The UI's task manager never sleeps, so a naive meter reads 100% forever. Races the top of its poll loop and drops it in the instant real work starts. Okay, so the keyboard event poll is charged idle, and menus drag clicks are charged busy. Okay, that's good. And the window. So one new bar plus a 2-column white gap per update, oscilloscope style, so an XT isn't asked to redraw 288 columns twice a second, with a live percentage, 2 memory bars, total RAM, with the 192 reserved shown as dither. And okay, so this one is going to show some reserve space. That's nice. And the 64K kernel segment broken into kernel, resident package free. All right, so it looks like we have a 64K kernel limit, and we're at 22 kilobytes more or less. When you load Minesweeper, okay, and 1 row per task with name, state, and CPU share with a bar. Okay, cool. And the QEMU, okay, so it's gonna run QEMU to take some screenshots and verify things. All right, so right now, if I click here, I can see that it decided to do some contracts and implementation for the scheduler, the task manager, the wiring, and documentation. It did the build, and now it's doing the verification, and then it's gonna do any fixes after it verifies. So again, much more. This is Opus, so it's much more organized in how it runs the workflows, and it's probably gonna come up with something useful, very useful. But we're still gonna try Fable afterwards, and then I may even consider using Codex with ChatGPT with its latest models and see how that performs. All right, let's see. Let's wait here. It's probably gonna take another 20 minutes or 10 minutes, and then we'll check back in. All right, so here it is. So it finished up with Opus, and it went ahead and verified its work. It decided to do its own verification at the end. It says, "Let me verify this myself," rather than trust the reports. So it didn't trust its own sub agents, but it did find a bug, and it found a cosmetic flaw, and it fixed it. So let's go ahead and try this right now. I'm gonna go ahead and go to a new tab again. And you can see here that this built out a lot more files than the other ones. And I am going to make XT. And it should load the emulator. All right, so this is 86 box, okay. All right, this memory test. I gotta see if I can disable that thing, because come on. Do I really have to run this memory test with a simulated machine? It does make it look very authentic, I have to admit, but all right. Job is loading. I think I'm gonna open source this when I change the name to something better. So if you recommend a good name, I'll consider it. All right. So here we go. So we got again, we got the clock, we got everything running. We got this B here, which has mimes and not mimes, Minesweeper. And we have go to special and we go to task manager. Ah, check it out. That's even more impressive. So we got this right here. We got the system that it takes up 0 CPU. You got clock. It's in sleeping. Oh, I see. So let me see. It's gonna, the clock is, I wonder if the clock skews. And I don't know what clock this is following. It looks more like a timer than a clock. All right, there's a lot of flashing going on. I wonder if that's something I'm gonna be able to like fix, given the way that this works. Maybe that's why they didn't do preemptive multitasking in the early Mac days, because it's causing too much flashing, and they said, oh, we can't ship that to people. So let's see here. We got CPU usage, which is expected. Then we got RAM, we have 256K, and we have 192K used. That's a lot more than I expected. So this, obviously we're using a lot of more RAM than I expected here. Free 64K. The kernel is 24K, and free is 40K. So I wonder if I close some of this stuff, what happens? If I close the bounds, so I only have 64K of memory to use, and then this is the actual, so 192K is reserved. I wonder why that is. Okay. And then if I close the clock, and if I close the notepad, okay, there's still a lot of flashing, but given that this is an XT machine, it's, oh, look at this. They're still running as part of the kernel. I don't think I want that. Well, the clock is running, the bounce is running. Why is that? Is it because they're minimized, they're not closed? All right, so this is giving me some insight into how this system is working, because I think I want to make sure that the applications close out. And also, I didn't ask it for any color, so this is okay. I think I'm gonna leave it like this because I do want to probably support monochrome displays in the XT machines when I start trying this out. All right, so there's one last model on the Anthropic side that I want to try, and let's go ahead and do that right now. I expect it to be very similar, if not exactly the same as this one. So, but who knows? Maybe it actually might do something different. So we'll see. Let me go ahead and do that. All right, so for this last round, I've decided to run Claude Code with Fable 5 and high effort against GPT 5.6 Soul with high effort. And I'm going to use the same prompt. on both. Now, Codex doesn't understand ultra code like Claude Code does. So I'm not sure what the outcome here is gonna be. So maybe what I'm gonna do here is I'm gonna go and change ultra code to use use a workflow, use multiple sub agents to add a task manager for this operating system that is part of the main operating system, not the apps disk. Okay? So I'm gonna make that subtle change and see which one. First of all, I'm curious which one is gonna finish faster and which one is gonna have a better output here, or a better result, I should say. All right, so I'm gonna go ahead and hit enter on this one and hit enter on this one, and then we'll check back probably in about 30 minutes here, and we'll see how it goes. All right, so this did not go as expected. We do have results, but what happened was interesting. So the Codex ChatGPT actually ended in 16 minutes and 50 seconds. I haven't run it, so I don't even know um, if it did a good job or not, or if it actually is going to boot. But it ended in 16 minutes and 50 seconds. Now, Fable ran into problems, and it worked for 1 hour and 21 minutes, and it verified everything. So let's see what it did here. So it added a task manager, which opens a window smaller than others, 2 kilobytes, hidden at boot like about. Okay. It shows a CPU load gauge plus history graph, similar to what Opus built. An oscilloscope style sweep, okay, same kind of thing. And it did something, self-calibrates away the UI's task busy pull. So maybe it's much more advanced than what Opus did. RAM, total convention memory, used kernel, but PSS plus the resident job packages image. All right. Okay, so it maybe the memory usage is going to be a little bit more defined than the Opus one. And task list, all 4 scheduler slots with name, state, run, ready, sleep, or and real per task CPU share. Okay. Schedule that increment now reprograms pit channel 0 to mode 2, and schedule counts attributes elapsed pit cycles, 1.19 megahertz resolution to the outgoing task at every tick, and yield using 32-bit ticks times 64K plus phase timestamps with pick IRR disambiguation, so full tick slices can't alias to 0. The US 93% share that was honest. All right, so this looks like it's gonna be really accurate or wrong. So we'll see. And then it probably hang just like the Haiku attempt failed. So it ran the workflow twice. Okay. All right. So here's what we're gonna do. I'm gonna try the ChatGPT version first. I'm gonna make XT and see how that one runs. Okay, so the machine is booting, and it may very well hang. Okay, here we go. 128K, 144, almost there. And it's loading. And it booted. Okay, that's a good sign. So we have the machine boot loaded. And if I go to special, oh, where's the task manager? Oh, it put it under file. Interesting. Okay, so this is the task manager built by OpenAI's ChatGPT in Codex. So we have the background CPU activity. Okay, so it decided to use one single graph for that. RAM used by job, okay, 22 kilobytes. Conventional RAM total 256 kilobytes. So it doesn't show that 64 kilobyte block that Opus decided was necessary. And then we have bounce is frozen right now. Why? Okay, come on. 5%. Okay, so it is using some CPU there. But we have four slots: the system UI, the clock, the bounce, the taskbar. The notepad is not running. So we definitely should increase the task count in a future to maybe like 6. I think 6 would be the limit of usability. Um, but what happens if I close this and I close this? It's sleeping. Okay. But it still takes up a slot. What happens if I open the notepad again? All right, it looks like the slots are taken, but this doesn't know that it doesn't actually do a good job of representing that. So maybe Fable did a better job. All right, so I'm impressed. ChatGPT built something in 16 minutes. That's faster, I think, than anybody else so far, than any other, not anybody, and than any other model. So let's quit this. And now let's try the Fable version. I have high hopes that this is gonna be good if it runs. It should run because it does this. That's the nice thing about Fable is that it verifies its work. All right, so here we go. We got the machine booting up again. And almost there, 192 kilobytes. 256. Job is loading. All right, and here it is. Okay, so we are gonna go to special, task manager, and the moment of truth. Oh, wow. All that work for this? Really? Let's see. It is much more accurate. So you see that you have the UI at 40%. You have the clock is at, it's measuring it much better, but it's so small. I do kind of like that it's small because of it fits nicely somewhere on the screen, like 640 by 480. But we still only have four slots. What happens if I put the clock to sleep? Okay. And then this. The clock is still using CPU time. So all these apps are running all the time. I'm gonna have to change that behavior. But the RAM here is reported as 23 kilobytes out of 256, which is much better than the other one. So I don't know. Do I like this one or do I like the Opus one? I think I'm gonna go with this one for now. I think it's a little bit more tidy. And I have a feeling that it's gonna be more accurate. At least that's what I'm seeing. It's showing the metrics more reliably and than what I saw with Opus. All right. Well, I am gonna end this here, and gonna merge this one in to the main branch so that we have the task manager running. And in the next video, what I think I'm gonna do is I'm gonna increase the total number of schedulers to be at least 6, and then maybe eight schedulers, and see how that works. That gives you on a 4.77 megahertz machine, it's gonna be each task is gonna progressively get slower. And then I'm gonna see if I can make it so that these tasks are not always running and actually shut down. So that would be really important. So let's see how that works. Okay, well, I hope you enjoyed this. And again, if you have any recommendations for what to name this thing other than job or jobs, leave it in the comments, and I'll consider it before I open source it. All right. Well, thank you so much. Bye bye.